Hello, my name is Juliana Madrich, and I'm pleased to present our paper AI-powered conversational assistance in augmented reality for multi-step tasks, conducted at Know-Center Research GmbH in collaboration with Graz University of Technology in Austria. Offering AI assistance for multi-step tasks remains a significant challenge. For our work has explored different strategies. Moore et al. Proposed retargeting technical documentation into structured AI instructions, while others rely on expert recordings to capture procedural knowledge. Although effective, these approaches still require substantial manual effort. More recently, LLM-based systems such as Satori have been used to ease authoring efforts. Insensible Agent, for example, demonstrated how LLMs can simplify user interaction through natural language understanding. These developments motivate our approach. We leverage LLMs to reduce authoring complexity while enabling more intuitive AI guidance. To evaluate assistance in industrial scenarios, we formulate 3 research questions. First, how does an LLM-powered conversational AI assistant compare to a baseline system in supporting procedural tasks? Second, how does task structure, whether linear, nonlinear, or conditional, affect the effectiveness of a conversational AI assistant? And third, how does such an assistance influence users' attention allocation and interaction behavior during task execution? Importantly, our system design is grounded in real industrial requirements. Tasks are based on official technical documentation. Moreover, many real-world tasks are not strictly procedural. They include troubleshooting and handover scenarios, which further motivates a flexible conversational assistance approach. Here we can see an overview of our system and study setup. We conducted a controlled laboratory study using the JuiceMixer testbed to simulate an industrial scenario. Participants performed the task by wearing a HoloLens 2. We compared 2 user interfaces in a between-subject design, a baseline AI system and an AI-powered conversational AI assistant. The system uses spatial AI anchors visualized as cubes in both conditions to register and reference task-relevant components in the environment. This setup allowed us to systematically evaluate the impact of conversational AI assistants under controlled but realistic conditions. For our evaluation, we designed industry-aligned tasks for novice users across 3 types of content navigation. First, linear content. Navigation provides simple step-by-step instructions helping participants familiarize themselves with the machine operation. Second, nonlinear content navigation presents more complex tasks that require additional information foraging and troubleshooting. Third, conditional content navigation simulates situations where an expert has already started a task and the participant must finalize the procedure. The study procedure follows a structured sequence. Participants start with an introduction to machine and user interface and training. Complete questionnaires, perform the linear tasks, fill out questionnaires again, then proceed through the nonlinear and conditional tasks with questionnaires after each, followed by a final debriefing. In the linear content navigation task, participants complete 6 sequential steps to familiarize themselves with the machine: filling and placing vessels, attaching lids, connecting and activating pumps, and retrieving the mixture. In the nonlinear content navigation tasks, participants face a more complex workflow that requires additional information and troubleshooting. For example, they must determine where to place the vessels by cross-referencing information, ensure the sensors are operated safely, and handle a misconfigured pump. In the latter case, the pump would not activate unless the correct flow rate was set, so participants had to either notice the required adjustment or consult the troubleshooting chapter. In the conditional content navigation task, participants start a procedure that has already been partially completed. In this scenario, the first step was correctly done, but the second step contained an error. 2 vessels had been placed but in the wrong positions. Participants needed to recognize and correct this mistake before continuing. Here we can see the 2 user interfaces used in our between-subject study with 18 participants each. On the left, we see the baseline interface without AI support. It shows the documentation, including buttons to advance through task steps, navigate between chapters, scroll through the document, and zoom in and out. On the right is the AI-powered interface. In addition to a documentation view, it includes a chat window that displays both the user's spoken input and the LLM's responses. The system also shows the corresponding page of the documentation to maintain transparency and traceability. To evaluate our system, we collected both quantitative and qualitative measures. On the quantitative side, we measured task completion as well as task completion rate and the eye gaze behavior. On the qualitative side, we used NASA TLX questionnaire, the system usability scale, and the user experience questionnaire. Finally, we included a post-study open-ended questionnaire. This slide shows the task completion times across all three tasks for both conditions. On the x-axis we see the three task types, and on the y-axis the completion time in seconds. For the linear and nonlinear tasks, we observe no significant difference between the interfaces. However, in the conditional task, the baseline interface without AI was significantly faster than the conversational assistant. To better understand this effect, we next examine the effect of task completion times, correcting for AI response latency to separate user performance from system delay. After correcting for AI response latency, we observe a different pattern. For the linear and nonlinear task, the AI-supported interface is significantly faster than the baseline. For the conditional task, however, there is no significant difference between the two conditions. This suggests that conversational AI support can be particularly beneficial for users who are still learning or navigating unfamiliar procedures. In contrast, for tasks that are already largely known, as in the conditional scenario, users may not substantially benefit from AI support. Here we can see the task completion rates across conditions and task types. Overall, we do not observe significant differences in total completion rates between the baseline and the AI-supported interface. However, there are two noteworthy effects. For the linear task, the AI condition achieved a 100% completion rate, whereas the baseline condition did not. In addition, within the nonlinear task, we found a significant difference for one specific step, the temperature sensor check related to safe operation. In this case, AI-supported users were significantly more likely to complete the step correctly. The assistant included the relevant safety information, whereas baseline users had to explicitly look it up and often missed that step. Here we can see the relative gaze times on key interface areas of interest. The eye tracking data reveals consistent differences in visual attention between the two conditions. Participants in the AI-supported condition spend significantly higher proportions of their time focusing on informative interface elements, such as the chat window, the documentation content, and the AI anchors. In contrast, participants in the baseline condition had to divide their attention between consuming content and operating navigation controls. Here we have the qualitative results. Overall, we do not observe any significant differences in perceived workload between the baseline and the AI-supported conditions across tasks. Both the system usability scale and the user experience questionnaire show similar patterns across conditions, with no significant differences between the baseline and the AI-supported interface. Overall ratings were slightly on the negative side in both conditions, which is likely attributable to the shared underlying user interface and interaction design rather than the AI component itself. The post-study questionnaire provides additional insight. Participants frequently reported frustration related to the AI response latency or user interface interaction issues, indicating that systems delay have a noticeable impact on the perceived experience. Here we have a summary of our findings with respect to the three research questions. Regarding RQ1, AI-powered AI assistants show potential for more efficient procedural knowledge acquisition. However, this enhancement is currently constrained by general AI usability challenges, and in particular AI system latency. For RQ2, we observe improved effectiveness of conversational AI assistants, especially in learned-oriented tasks. This is reflected in improved task completion rates and efficiency after correcting for latency. However, for already known tasks, manual content navigation appears to be sufficient. Conversational support does not necessarily provide an additional benefit. Finally, addressing RQ3, we see a clear shift in attention allocation. Users interacting with the conversational assistant engage more visually with procedural knowledge, focusing on informative content rather than navigation controls. We also acknowledge several limitations and challenges of our work. From a technical perspective, the cloud-based LLM introduced noticeable latency, which directly affected efficiency and user experience. In addition, usability constraints of the HoloLens interface influenced overall interaction quality. Regarding the study design, our controlled laboratory setup allowed systematic comparison, but it may limit generalizability to real-world industrial environments. Furthermore, the repetition of a standard procedure may have introduced learning effects across tasks. Finally, the scope of our AI assistant was limited. The system was primarily reactive, relying on in-context learning and user-initiated queries. It did not incorporate visual context awareness or proactive guidance strategies, which represent important directions for future work. In conclusion, we demonstrated the potential of conversational AI assistant in AI-guided tasks. Our results indicate that AI support is particularly beneficial for learners, improving efficiency in task completion in knowledge-intensive scenarios. At the same time, the findings highlight the importance of improving AI response time, as latency remains a critical limiting factor. For future work, we plan to explore adaptive AI systems that dynamically adjust the level of instructional detail based on user experience and task context. Additionally, we aim to enhance the system with visual guidance elements such as integrated visual strategies, and more comprehensive support strategies. Thank you for your attention.